Hello everyone. Today we are going to start a new chapter, motion in a plane, which is also known as vector. According to the latest syllabus given by CBSE, the topics that we need to study in this chapters are scalar and vector quantities, position and displacement vectors. We need to see what is position and displacement vectors. Then general vectors, there are different kind of vectors. We will know what their definition, what is the meaning and their notations. Equality of vectors, multiplication of vector by a real number, addition and subtraction of vector, relative velocity, unit vector, dissolution of vector in a plane, rectangular components, scalar and vector product of vectors. Then we will study about motion in a plane, case of uniform velocity and uniform acceleration projectile motion and uniform circular motion. So these are the things that we need to study in this chapter. So let's start the chapter now. First thing, if we talk about that what is scalar and vector quantities, so I think all of us knows that scalar quantities are those quantities which does not have any direction, have only magnitude. If for example distance, speed, mass, energy, work, and vector quantities are those quantities which have magnitude as well as direction, means they will have a specified direction. So scalar quantities can be classified as those physical quantities which only have magnitude but no direction, and vector quantities are those physical quantities which have magnitude as well as direction. Okay, after that we have what is position and displacement vector. So if any vector is a vector which gives position of an object with reference to the origin. I repeat myself, any vector which gives position of an object with reference to the origin of a coordinate system is called position vector. Suppose you can see here, suppose the motion of an object in xy plane with origin at O. Suppose an object is at point P, here the point is P, at any instant of time t, you can see the figure here. Then this OP is a position vector of the object at point P. Now the position vector provides two information. It tells the straight line distance of the object from the origin O, and it tells the direction of the object with reference to the origin. After that, what is displacement vector? Suppose here only, if the object is moving from point P to point Q, so this PQ will be the displacement vector between this PQ. It is that vector which tells how much and in which direction an object has changed its position in a given time interval. Suppose an object is moving in xy plane. It is at point P at any instant time t, and at point Q after some time. So you can see in the figure here. So this PQ will be the PQ vector. This PQ vector will be the displacement vector of the object from this time to this time. So position and displacement vector is clear. If you have any query here, you can tell me in my WhatsApp. After that, we have some general vectors. First vector is equal vectors. Two vectors are said to be equal if they are having both equal magnitude and equal direction. Suppose if I say like this is A vector and this is B vector, you can see the magnitude is same and the direction is also same. So these two vectors will be known as equal vector. What is negative vector? Negative of a vector or negative vector. Two vectors are said to be negative of each other if they are having equal magnitude but opposite direction. You can see here A and B is having equal magnitude, but the direction of A and B is different. So if we want to write B in terms of A, we need to write minus A vector. After that, we have modulus of a vector. What is modulus of a vector? The meaning of modulus is a magnitude. Suppose if you want to find the modulus of vector A, then at that time we will just take the magnitude, we will not take the direction. The modulus of a vector means the length or the magnitude of that vector. It is a scalar quantity. After that, we have unit vector. What is unit vector, sir? A unit vector is a vector of unit magnitude drawn in the direction of a given vector. This unit vector is having unit magnitude and it is drawn in the direction of the vector. Unit vector is shown by this hat. We can say this, sometimes we say hat, sometimes we say cap. it is always shown in the direction of the vector. You can see here, suppose this is a vector A vector, and if you want to show, so this is a mod. If this is a mod, we need to show direction also, because we know that mod shows the magnitude only. Then how we can show the direction? We can show the direction with the help of a unit vector in the same direction. After that, if you want to find the unit vector, it will be the vector divided by the mod. This is the formula, and we have three unit vectors along three direct coordinate axes. Along x-axis we have I hat, along y-axis we have j hat, along z-axis we have k hat unit vector. Okay. After that, we have some fixed vector. Fixed vector are those vectors whose initial point is fixed is called fixed vector. What is free vector? A vector whose initial point is not fixed is called a free vector, or we can say non-localized vector. After that, collinear vectors. Two vectors or more vectors are said to be collinear if they act along the same line or along the same parallel lines. Okay. If they act along the same line or act along the same parallel lines, then we can say that the vectors are collinear vectors. What is parallel vectors? These are the parallel vectors. What is anti-parallel vector? This is anti-parallel vectors, or we can say this is also as anti-parallel vectors. After that, we have coplanar vectors. The vectors which act in the same plane are called coplanar vectors. What is co-initial vector? If the initial point of some vectors are same, then we can say that this is the co-initial vectors. What is coterminous vectors? If the ending point of some vectors are same, then we can say that the vectors are coterminous in nature. So this is done. We know now what is scalar and vector quantities, what is position vector, what is displacement vector, some general vectors and their notations also we know now. After that, we have equality of vectors. How we can say the two vectors are equal? Two vectors will be said equal vectors if their magnitude as well as direction is same. That we discussed here only. The two vectors are said to be equal if their magnitude as well as direction is same. After that, we have zero vector. Zero vector is also not done. A zero vector is a vector whose that has zero magnitude. So the magnitude will be zero. Magnitude will be zero, and an arbitrary direction means it can go in any direction. It is represented by this zero vector, like this arrow over the number 0. I repeat myself, a zero vector or null vector, it is also said null vector, is a vector that has zero magnitude and arbitrary direction. It is represented by zero vector. Now, sir, if the magnitude is 0, then what is the need of a zero vector? There is always a need of zero vector, that I will make you understand. Suppose if two vectors p and q vectors are equal vectors, then what will be the value of p vector minus q vector? Obviously the magnitude will be 0, but the direction cannot be 0. At that time we need zero vector to show the difference of two equal vectors. I repeat myself, if p vector is equals to q vector, then what will be the magnitude of, what will the result of p vector minus q vector? It will be zero vector. Okay. So these are the need of zero vectors, and what are the properties of zero vector? Zero vector, when a vector is added to a zero vector, we get the same vector. Suppose if we write a vector plus zero vector, we will get a vector only. When a real number is multiplied by a zero vector, we will get the result as zero vector. When a vector is multiplied by 0, we get zero vector. If lambda, suppose if there are two non-zero real vectors, suppose one is lambda and one is mu. If lambda and mu are the two different non-zero real numbers, then the relation we can hold as lambda a vector equals to mu b vector. This can hold only if both a and b are zero vectors, otherwise not. Because if a and b are not zero vector, the result will be different by multiplying with different real numbers. Now we will see about the multiplication of a vector by a real number. if we multiply, how we can multiply, the next topic is multiplication of vectors by real numbers. So how we can multiply a vector by real number? Now we are going for multiplication of vector by real number. Multiplication of vectors by real number. If we go about the multiplication of vectors by real number, then what we will see here, suppose when a vector is multiplied by a real number lambda, we get another vector lambda a vector. The magnitude of lambda a vector is lambda times the magnitude of a vector. If lambda is positive, then the direction of lambda a vector is same as that of the a vector, and if lambda is negative, then the main direction of lambda a vector will be opposite to that of a vector. And yes, suppose this is a vector and this is also a vector, so this b vector will be equals to 2a vector, it is getting double. If v vector is equals to minus 2a vector, it is getting doubled, but the direction is being opposite. Okay, after that we have how are the this is the example. If a vector is multiplied by a real number 2, lambda equal to 2, then we get another vector v vector such that b vector equal to a vector. As shown in figure here, you can see here the magnitude of b is becoming twice that of a, and the direction is same because that was a positive quantity. But if a vector a is multiplied by minus 2, then we can see the magnitude is being double, but direction is being opposite. Why the direction is being opposite? Because this the value is what, minus 2, and we saw now only, we discussed now only, if it is getting multiplied by a negative real number, then the direction will become opposite to that of the original vector. Now we will discuss about addition of vector and subtraction of vectors. So first let's go for the addition. Okay, addition, the resultant of two or more vector is that single vector, we can say composition. Addition has one more name, composition. So the resultant of two or more vector is that single vector which produces the same effect as the individual vector together would produce. So the process of adding two or more vector is called composition vector. But we cannot add vector by a simple algebraic method. To add vectors, we have three different laws. In which the first law is triangle rule of vector addition. Then we have parallelogram rule of vector addition. And then we have polygon rule of vector addition. That is our next thing. That is our next job. You can see here triangle rule of vector addition. So first let's focus on the statement of the triangle rule of vector addition. If two vectors can be represented both in magnitude and direction by the two sides of a triangle taken in same order. What's the meaning of taken in same order? It means they are going in the same direction. Taken in same order, then the resultant is represented completely both in magnitude and direction by the third side taken in opposite order. What they want to say, if there are two vectors, a vector and b vector, they are shown by the two sides of a triangle, both taken in same order, they are going in the same direction, then the third side of the triangle will give the resultant both in magnitude and direction, but must be taken in the opposite order. You can see here a and b is going in this direction anti-clockwise, and this resultant with the third side is going in the opposite direction, that is clockwise. So, and you can see this a and b vector we have just adjusted in somehow, that b we fixed here without changing its direction. So we saw that a and b vectors are represented by the two sides of the triangle. Then we need to show that the third side, we know that the third side will give the resultant both in magnitude and direction, but must be taken in the reverse order or opposite order. So suppose two vectors a and b are initially inclined at angle theta. A and B inclusive. So how we can show the angle between A and B? This will be the angle between A and B, which is theta. Okay, so now we need to prove, we need to find if it is there, sir, then what will the value of R in terms of both magnitude and direction. So now we need to find the value of R. First we'll find the resultant value in terms of magnitude. So we know that A and B are the two vectors inclined at angle theta. So you can see here, I have just shown a complete diagram of this here. This is OPQ triangle, this is OPQ triangle, this is A vector, this is B vector, this is resultant vector shown by R vector. The angle between A and B vector is theta, that I have shown here. Phi is the angle made by the resultant with the A vector. We need to find the value of R vector in terms of theta and all, and theta A and B, and then we need to find the value of result direction also. So if what we will do, we will first draw a perpendicular from the point Q on the produced part of OP. On the extended part of OP, suppose the point is M, the point of perpendicular is M. After that, we can see here that this is a right angle triangle. The whole OQM is a right angle triangle. We can use Pythagoras theorem there, that this square equal to this square plus this square, that I have written here. But this OM can be further divided into OP plus PM, and also I have done here. So OQ square equals to OP plus PM ka whole square plus QM square. Now this is A plus B whole square, which can further be classified, further be divided into A square plus B square plus 2AB. After that, what we can do, we have the value of we know the value, we don't know the value of QM, that we need to find. We know the value of OP is A. PM also we don't know, that we need to find. So to find the value of OQ and PM, what we will do, in this triangle, this small triangle PQM, first we are finding sine theta. Sine theta is what? Perpendicular by hypotenuse. So it will be QM by PQ. When we are finding QM by PQ, then QM will be equals to PQ sine theta. Now what is PQ here? PQ value is what? B vector. So QM will be equals to B sine theta. After that, now we have the value of QM. After that, we will go for cos theta. Cos theta is what? Base by hypotenuse. So it will be PM by QP. From there, we can find PM as PQ cos theta. What is PQ here? PQ is B vector. So it will be B cos theta. So QM and PM value now we have. Now we are putting this value in this equation. What is OQ? OQ is R vector R. So it will be R square. QM will be B sin theta. B sin theta square plus OP square. OP will be A square plus PM square is B cos theta whole square plus 2. OP will be A and PM will be B cos theta. Now the square of this will be B square sin square theta, A square B square cos square theta, 2AB cos theta. Now if we take this and this together, and if we take B square common, the result will be B square only, because sin square theta plus cos square theta will give us a value 1. Then it will be A square here plus 2AB cos theta. Therefore R will be under root A square plus B square plus 2AB cos theta. So the value of resultant in terms of magnitude, we have the magnitude we have of the resultant, which is A square plus B square plus 2AB cos theta. Now we need to find the value of the phi, and the value of phi will give us the direction of the resultant respective to A. If we find tan phi, what we'll get? We'll get perpendicular by base, that is QM by OM. Now OM can be further divided into OP plus PM. So QM by OP plus PM. QM is given as, we got it here, QM here. It is B sin theta, that would be I written here. Then OP is A and PM is B cos theta. So therefore tan phi will be B sin theta by A plus B cos theta. So what is the value of phi? Phi will be equal to tan inverse B sin theta by A plus B cos theta. So this is the direction of the resultant vector in respective to vector A. So this is triangle rule of vector addition. Similarly, we have two more rules, parallelogram rule of vector addition and polygon rule of vector addition. But in both the rules, to find the resultant will be same as it is only. And to find the resultant, they have used triangle rule only, the properties of triangle only. So that I think that you can do by yourself. But that the initial diagram of the parallelogram rule, that I can show you right now. So if we talk about what is parallelogram rule of vector addition, then first we need to know the definition of that rule. Now, what is parallelogram rule of vector addition? If two vectors can be represented, let me draw the diagram first. So according to parallelogram rule of vector addition, if two vectors can be represented that both in magnitude and direction by the two adjacent side of a parallelogram, this you can see these are the two adjacent side of parallelogram of a parallelogram drawn from a common point. You can see that this is drawn from a common point. Then the resultant is completely represented both in magnitude and direction by the diagonal of that parallelogram drawn from the same point. So you can see here this A and B are the two vectors shown by the two adjacent side of the parallelogram taken from the same common point. Then the resultant will be shown by the diagonal which is taken from the same common point in both magnitude and direction. So and you can show here also that r equals to under root a square plus b square plus 2ab cos theta, where theta is the angle between the two vectors. And one more thing we can see, say we can take this angle as phi. Then you will take you can prove that tan phi equals to b sin theta by a plus b cos theta. So these are the things that you can do by yourself. Again, to do this, I'm giving a hint. You can draw a perpendicular here. You can name the point as A. So this will be a perpendicular. Again, you use Pythagoras theorem, and the same thing you follow that we followed in case of triangle rule of vector addition. Then this will be done. After that, you can do polygon rule of vector addition. So these three you can do by yourself. And after this, with this I'm ending this video. In the next video, we'll see what about relative velocity, resolution of vector in a plane, rectangular components, scalar and vector products of vectors. And after that, one more video I will make in which we will see about motion in a plane, case of uniform velocity velocity and uniform acceleration. So that will be a projectile motion case, the next part of this chapter. So at least 3 videos we will be going for in this chapter.